Well, hello. Welcome to another episode of Custom Micro. I don't know if we call it an episode, but at any rate, this is our first and ever live stream. And it's been a long time since we put any content out there. In fact, it's been well over a year since our last video, and for that I sincerely apologize. You may have been wondering what's going on with Custom Micro. If they stopped producing content? Well, very busy and was focused on the work, but I hadn't forgot about y'all. And I know you might have thought, well, we're just kind of a one-man band, and all we focus on are FS switches. Really enjoyed the video series going through talking about FS switches and how to configure those from both the graphical interface and the command line. But today you get a little bit of a different peek about really what Custom Micro is all about. So we support small and medium businesses. We do server systems, of course, desktops, workstations, laptops. We're basically a full-service IT managed service provider. We do phone systems using freepbx and sangoma phones, and there's just almost nothing related to IT for small and medium businesses that we don't cover. And we could even do access control and other things. So, but anyway, I thought I would share a little inside glimpse of what's a project I'm currently working on. In this project, I'm actually building 3 servers for 2 different doctors' offices. One of those doctors' offices is going to have 2 of these servers in a failover cluster, and that'll be nice for resiliency, and I'll explain more about that in a little while. But I thought I'd just bring you along for the ride this evening and talk about the different components I chose for this server build and why I chose them. And I would love to hear feedback, so if you hop on the live stream, if you want to leave a comment about, maybe ask a question why I chose a particular component, mention why you think that's a dumb idea or a great idea. And again, this will be a different format. It won't be quite as polished. This is live, so when things are live, we'll just see how it goes. So I have some things queued up to show you and explain some things. But again, it's good to be back in the saddle, and I hope you enjoy just kind of having a more of an intimate look at Custom Micro. So with that said, let's take it away. Let's see here. I'm going to go in here and check this. For some reason, I have had nothing but technical difficulties here lately. It's really weird. So it may be because of something I have open here. Let me close that. Let me go back in here, change that. Okay, boy. Trying to get all this technology to work, and you see we're recording in a new location, so that doesn't help, and we're using some different technology. We're using a different phone for the camera, using NDI, which you're not familiar with NDI. It's a really cool technology for streaming video, and that's a whole other video for another time, but I do have quite a bit of experience with some of that, so we could definitely have some content related to that. But anyway, let's talk about the components I chose for this server build. By the way, just to, I guess, to lead out right out of the gate, this server build cost right around $6,000. And I know it might be hard to believe there's $6,000 of components here, but if you noticed in the title, this is a all-flash server build. The majority of that flash storage being NVMe. And so this server is no slouch, and this is a screaming small business server. So I kind of like to explain a little bit about why we chose these components, and if you're looking at or interested in building something similar, maybe I'll give you some ideas. And so the first thing we'll talk about is the motherboard. And you know, I've been a fan of ASRock Rack for a while now, and the primary reason I like to use ASRock Rack boards is because they have an out-of-band management chip. In fact, the board I'm using for this build is the ASRock Rack B650D4U-2L2T/BCM. And I chose this board because just like when you're building a server, you base it on their platform. Well, this platform is the socket AM5. This is for the current gen AMD Ryzen Zen 4. I'm going with the AMD Ryzen 7000 series, the 7950X. We'll talk more about the CPU in a moment, but because that was the platform I chose, this is the motherboard I chose. Again, if you look down at the specifications, it does support more than just the Ryzen 7000 series. It supports the newer 8000 series, and the AMD EPYC 4004. It does have 4 DIMM slots with a big caveat, and we'll talk about that in a little bit. And it has about as much PCIe as you can squeeze into a Ryzen Zen 4 chip, because you only have about, I think, around 28 PCIe lanes total. So we've got one PCIe 5.0 times 16, so 16x slot. We have a 4x slot that's PCIe 5.0, a 1x slot that's PCIe 4.0, and then one M.2 slot on the motherboard that also is a PCIe 5.0 4x slot. This board also has 2 10 gig 10 base T ports. These are actually Ethernet ports. They're not transceiver ports, so keep that in mind if you're looking at this board. You'll need to make sure your switch either has 10 gig Ethernet that you're going to plug this into if that's your desire, or that you buy the modules that plug in the transceiver port that will convert that to a 10 gig Ethernet. It also has 2 Intel 1 gig Ethernet ports, 4 SATA ports, and then it does have HDMI and DisplayPort, but because we're running this headless in a cabinet, going to be rack mounted, we really won't need that. And that's also a big benefit of the out-of-band management IPMI. If we scroll down here on the specifications, I'll talk about the little caveat I mentioned earlier about the board having 4 DIMM slots. Because of the nature of the integrated memory controller on these AMD Ryzen Zen 4 chips, you can only run 2 memory sticks or 2 modules in dual channel mode in order to get the optimal speed. You notice here it supports, of course, ECC and non-ECC memory. We'll talk about that in a moment. And if you only have 2 memory modules, you can run at least at 5200 megahertz. I'm actually running this kit at 5600 megahertz in this build because I may have not mentioned it earlier, but this is the third of 3 servers I'm building. I've already built the other 2. One has already been deployed. It's already in production, waiting on some software people to do some stuff there. But if you max this out and fill out all 4 slots on your memory, that will drop your speed down to 3600 megahertz. And again, you notice there, if you have 1 DIMM per channel, you can run at the faster speed. 2 DIMMs per channel, it drops you down to that slower speed. And because I wanted to have the optimal speed on this server, I didn't want to. That's a drastic decrease in your bandwidth of your memory. I'll talk to you about a unique thing I did in my selection of memory for this system. We'll get to that in a little bit. But it does have this out-of-band management controller, the BCM, the ASpeed AST2600. It has its own dedicated gigabit Ethernet port for management. And this allows you to basically pull up a console window. You can actually see what would have been on the display in a headless mode where you're not plugged up any kind of monitor, mouse, and keyboard. In essence, it becomes a remote KVM, a remote monitor, mouse, keyboard kind of scenario. The benefit of, you can actually go into that web interface through an IP address. You can actually pull up that console. They have both an HTML5 variant and a Java variant of that console you can pull up. And you can control the computer just like you're sitting there with a monitor, mouse, and keyboard. Also, you can power the server off, power it on. You can get into the BIOS. You can update the BIOS and the firmware. You can do all that remotely. So when I build servers that are in critical 24/7 environments, I always make sure I buy a motherboard that has the IPMI out-of-band management port. Your mileage may vary. You may not have a need for that, but this is a lifesaver. Just think about a scenario where there's a power outage, power comes back on, the server should have started back up automatically, but for some reason it doesn't. You're going to have to make a trip to that business to get that server started back up, but if you have the out-of-band management, it's on all the time. As long as the server has power, that chip boots up, and you can open up that web GUI, and you can power that server back up with just a click of a button. So definitely an important thing to consider. So this is the motherboard I chose. Again, it's socket AM5, and it supports these different AMD CPUs. One of the big reasons I went with AMD over Intel, in order to be able to support ECC memory on the Intel platform, you have to have Xeon processors. And although I would have loved to have a true server-grade CPU, both the Intel Xeon chips are really expensive, and the AMD EPYC line of CPUs are very expensive. They were way out of the budget range for these businesses. And the AMD EPYC, they do have 128 PCIe lanes, which is wonderful. Could have had a lot more peripherals. Could have probably had some either 25 or 40 gigabit Ethernet cards network cards in this. But alas, we really couldn't afford those AMD EPYC chips. Those can run well over $1,000 and the sky's almost the limit on the price of those. So I decided to go with a consumer processor because the AMD Ryzen Zen 4 chips do support ECC memory. The consumer processors support ECC RAM, which to me is important because that can correct single-bit errors with your memory. And when the server's running 24/7, 365, there's a chance there could be a bit flip, and so this can correct that and keep that system stable. I know that with the new DDR5 technology, there's a little bit of a type of ECC kind of baked in, but this is a level above that. And we'll talk more about the memory we chose in a moment. This is the board I wish would have been available when I was building these three systems. I actually bought all these parts back in November of last year. That shows you how busy I've been, that I've just now been able to kind of build these servers and start to get them deployed. But this board is not even out in the market yet. It's just now been kind of announced. But this board is basically virtually the same exact motherboard with the added benefit that it has two 25 gigabit transceiver ports, which is, I would have chose this because in one of the doctor's offices where I'm doing a failover cluster scenario, having the fastest data plane, for that network connection is very important. And so you do lose some of your other connectivity. You lose that one PCIe 5.0 PCI Express slot, and that drops down to PCIe 4.0. And so you do have some trade-offs there to get those 25 gig transceiver ports, but I would have definitely went that direction if that would have been possible. Okay, well, you're probably getting really tired of talking about the motherboard, and so I'm just going to take a little trip down memory lane here, if you will, and just kind of explain some things. So just a little, I guess, a story, if you will, maybe an interlude to all this, if you're tired of all the techie talk. I guess this all started, my venture into becoming kind of a tech enthusiast, started back around circa 1993. My parents purchased a Packard Bell 486 computer. This computer had a 25 megahertz Intel processor. It was an SX series, not DX. DX had a math coprocessor, so this was a very stunted CPU, only 25 megahertz and only an SX series. It had 4 megabytes of memory, and it had a 200 megabyte internal hard drive. There was no CD-ROM drive, no DVD drive, of course, no sound card. It had a 5 1/4 floppy and a 3 1/2 inch floppy drive. And that was my first computer, and I learned an awful lot about that. I did my first upgrade. I installed a Creative Lab Sound Blaster 16 ISA card. Long before PCI Express slots, before PCI slots was the ISA slot. Now, this was a 16-bit ISA slot and card. But just a little fun fact, back in those days, because you typically had limited connectivity on your motherboard, there wasn't nearly as much integrated on the board. That Sound Blaster 16 card had an IDE connector on the back, one of those, probably back in those days, like a 66-pin IDE connector. I think it was before the 80-pin connector, even, where you could plug, like, let's say, a CD-ROM drive in there if your motherboard didn't have a spare IDE port. So really fascinating that a sound card would have an IDE port on the back. And but that was just the nature of the way things were back then. A lot of times, my first computer I built was about a year later, when I was about 14, 15 years old, somewhere in there. And that first computer that I built, I believe, was 133 megahertz. It was an AMD chip, and I don't remember how much memory it had or any of those other specifications, but I just remember that was quite a learning experience. And so here we are, all these many years later. I mean, at this point, it's almost 30 years later, and still a tech enthusiast. I still get excited to talk about technology, to work on technology. And although I may not be able to or want to afford a $6,000 server for myself in my home lab, I can build them for someone else, deploy them, and be able to tinker with them and enjoy the technology and then send that on its way. And so hope you enjoyed that little story, a little background of where I came from. I'll leave you with one last funny thing. All the way back then, what I was going to mention earlier, before the ATX platform, motherboards were simply an AT platform. That means that there was a DIN connector on the back about the size of a nickel that plugged the keyboard for the keyboard to plug into. And other than that, the motherboard didn't have any risers. There was no USB, no serial. All that came off the motherboard on a riser cable, and it would be a punch out on the back of the case for those COM ports, like a 9-pin COM port or a 25-pin parallel port. And of course, if you wanted a video card or sound card or anything like that, there was an extra card that was typically plugged in. It was maybe there was occasionally you'd see integrated graphics on a board in those days, but you certainly wouldn't see integrated sound and the like. And so it was definitely a very different time. But remember when I bought my first motherboard from a company that's defunct now, doesn't even exist now. Basically, when I bought that motherboard, I remember looking through the catalog. Yes, a catalog, not on the internet. And they said the motherboard had a new riser. It wasn't even built into the board. It was just a riser, set of riser pins that supported Universal Serial Bus, USB. And I thought, what in the world is that? It was so new that really there were no peripherals with it yet. You didn't see USB mice or other USB peripherals. Certainly no USB printers. Everything was parallel port and all that. And so I remember contacting this company and asking them what in the world was a Universal Serial Bus port. And they said, oh, it's going to take the place of your COM port and your parallel port and all these other ports. It's going to be this universal port for everything to plug into. And I'll never forget my comment, my statement back to that person was, I said, that'll never catch on. And how wrong I was. Now everything is USB. And here we are, many iterations through USB, many generations, all the way to the USB-C interface. And now USB 4.0 and all this, and we can do like 40 gigabit per second over USB. So we've come a long way. But anyway, that's the little interlude. That's my little story. So now let's go back and talk more about the components I chose for this server build. And I apologize if it seems a little erratic. I tried to do all this a couple days ago, recorded the entire 45-minute video, and then I realized there was no audio, or the audio and video was extremely choppy, so I had to just can that whole video and start over. So I feel like I've already been through this. It's like deja vu, and so forgive me if I seem a little scatterbrained about the direction and maybe the choice of the order of things. And so if we go on down the line here, let's talk about the processor and why I chose this. I chose the AMD Ryzen 9 7950X. And you may say, well, why didn't you choose the top of the line 7950X 3D? And I'll explain that to you. So the X3D is, definitely great for gaming. In fact, you don't even want to get the 7950 because it has two CCUs. AMD uses like a chiplet design on their processors. So 8 of the cores are on one chiplet, 8 of the cores are on the other chiplet for this 16-core CPU. But on this CPU, if you buy the X3D variant that has the 3D V-cache, they only put the V-cache on top of one of those CCUs. So only 8 of your cores can take advantage of that. And there's all this logic and special driver that's required for Windows 11 for it to be able to, kind of figure out when it should use the cores with the 3D V-cache. And basically, if you're gaming, it turns off the other 8 cores that aren't using the 3D V-cache. It's really kind of a clunky process there. And so for me, I went with the 7950X, so all cores on both CCUs get the maximum performance they can get, and I really don't need the 3D V-cache. This is going to be a virtualized environment. This is a physical server, but it's going to be running a bunch of virtual machines, virtual servers. So I picked this processor. It does have 170 watt TDP, which is probably the biggest hurdle I have in this 2U chassis build to try to cool that processor with 170 watt TDP. The 3DX variant does have a lower TDP, so that would have been one reason I did struggle a little bit with my choice because I would have liked the lower TDP. This does have a 4.5 gigahertz base clock and a 5.7 gigahertz boost clock. I have ran this thing through its paces with a Noctua NH-L12S cooler that I have on it, and it'll run about 10 minutes without doing anything in the way of thermal throttling, and then it begins to thermal throttle if you're using something like Prime 95 and pushing all cores to max and just heating those things up. The cooler can't completely keep up with the TDP, the wattage of this processor, but I'm never going to be running all cores at 100% maximum, and so it's not going to be an issue. I should, in most of my testing, I'm still boosting up into 5.7 gigahertz for a lot of the stuff I'm doing, and so but this is the processor I went with. It does have 16 cores, 32 threads, and just a good chip for what I'm doing here. And so you notice here, I said earlier I thought it was 28 PCIe lanes. It's actually 24. Maybe I'm thinking about the new Zen 5 they just announced. They might have added a few more PCIe lanes, maybe 4 more, but it is 24. So you're very limited on that, and it does limit on the amount of additional cards and even additional storage that you can use. And so that's a good lead-in to the cooler that I chose, because this was absolutely the best cooler I could choose for a 2U chassis that wasn't going to be super loud. There's some other brands that make coolers that are designed for server chassis that have these big Delta fans that sound like a jet engine when they're running. I'm big on silent or very quiet workstations, desktop servers, doesn't matter to me. Been a fan of Noctua for decades now, about as long as they've been around, I think. As soon as they came on the scene, I was right in there buying their super expensive fans. And they're still expensive, but in the very, very early days, they were way more expensive than other brands. But their coolers, their fans are really the best. And you can call me a fanboy if you want to. I think there's finally some competition out there, people making some fans that can compete. But for a long time, they were the king in that area. This cooler is the biggest I can fit. This thing's 70 millimeters tall, and there is literally about 1 millimeter space between the top of the heatsink and the lid of this 2U server. And so I'll explain a little bit more about how I cooled this. So let me transition over here. So basically what I did, and I don't have them right here with me, but I bought these 140 millimeter magnetic fan grills. So they're little magnetic strip around the perimeter of that square fan grill. And what I did is I took some nibblers, which allow you to cut very straight lines in the center of metal. Use some nibblers, and I cut out a square hole, and right above where the heatsink of this Noctua cooler is, and then I stuck one of those magnetic fan grills, if you want to call it that, or magnetic mesh filters on top of that. And so that allows that hot air not to get trapped in that 2U chassis and just circulate around, and maybe some of it go out the back, but by and large it'd be a lot of that heat being recirculated in the system. A lot of that heat should go straight out through that hole in the top of the lid. And so that's what I did there. And you'll see some pictures of that here in a little bit. And so that's why I chose the NH-L12S, as it was the biggest heatsink that I could cram into this 2U chassis. I could have went with a 3 or 4U and had a bigger cooler, but I just want to cram the maximum amount of performance I could into this small of a chassis, and also keep the dimensions where they need to be to fit in the wall mount cabinet. Talk about that in a little bit. You got to really take that under consideration. So as we transition back over and we're looking at the next thing, this is maybe one of the more controversial things I did, and maybe one of the more interesting things I did. You know, we think about memory nowadays. You got your 16 megabyte. I'm sorry, where am I at? I'm back in 1994. You've got your 16 gigabyte, your 32 gigabyte, 64, 128, etc. That's what you commonly think about when you're talking about a memory module. But the modules I chose are 48 gigabyte modules. That's been around now for maybe a couple of years. It's a relatively new density of memory module. But I chose this for a very specific reason. Remember how earlier I told you that this is a dual channel motherboard, and if you run 2 memory modules, 2 sticks of RAM, then you can get that maximum performance. But if you go ahead and fill out all 4 slots, you're going to drop that performance of your RAM, because that integrated memory controller just can't handle that much. DDR5 memory is a little bit of a different animal. In essence, it almost has some dual channel capabilities built into the module itself. And so when you have 4 modules, you're really pushing the system, and there's some parallel stuff happening there. And so what I want to do is have the maximum capacity I could get in this chassis, in this platform, for this motherboard and processor, the maximum capacity without losing any performance in the memory, and still having ECC memory. So these are 48 gigabyte modules for a total of 96 gigabytes of memory. I have 2 of these, and dual channel, obviously. Now, Also, I mentioned earlier I was a big proponent of using ECC memory in your server build. Keep in mind, a lot of times when you're building a server that's based on a lower end Xeon processor or a consumer chip like the AMD Ryzen 7000 series, that you have to make sure, if you look at your motherboard specifications, make sure most of the time it's going to be unbuffered DIMM. And you have to really watch for that because a lot of ECC memory is registered DIMM. They have registers on the memory module that help with really large capacity memory modules in the motherboard, the chip, integrated memory controller on the processor, able to deal with all the accessing the different cells, if you will, of that memory. And so these kind of systems here, you can't use registered DIMM. If you will, they won't fit in the socket, and if you do, you'll probably break it and they'll not work properly. So you need to make sure you get unbuffered DIMM, UDIMM. This is 5600 megahertz and it's running at that speed, so it's even a little more, I don't call it overclocked, but it's just running in its rated spec and speed. And it is, of course, ECC memory. So you might say, why Axiom? That's such an odd brand for that. Well, they're kind of an OEM manufacturer. I believe these may be Hynix chips or something on there. I'm not really sure. They may be Micron. I'm not really sure who makes the chips on there. I haven't looked closely. Regardless of that, there's not many options when you're looking for 48 gig modules that are ECC, unbuffered DIMM, DDR5, 5600. So because there was such slim pickings, this is what I went with. And it still has a lifetime warranty. Yeah, it's not Crucial. It's not Kingston or other brands of server memory you may be familiar with, but it is good memory. So far, the two servers I've built haven't had any issues with the memory. Power supply. Again, fanboy time, if you will. I've been using Seasonic power supplies for well over 20 years now. I've been using them since I first really started into doing IT work for a living, which I switched and transitioned from being a hobby to doing this full time circa 2003. And from that time, within that first year, I discovered Seasonic power supplies, and I have never looked back. And so you may say, well, why Seasonic power supplies? Well, they've been in this business a long time. They use exceptionally good components, and they have exceptionally good warranties. Some of their power supplies have as much as a 15-year manufacturer warranty. The one in particular here that I've chosen, it's a 650 watt. It is a platinum level power supply, 80 plus watt platinum, or 80 plus platinum, and it has a 10-year warranty. This is a fully modular power supply, and it does have the adaptive or hybrid fan situation. So the fan won't even kick on unless it gets up and needs to it needs to pull enough amperage. What I've noticed, even running Prime 95 on this server for an extended period of time, the fan never kicked on. That's how efficient this server is. Even running a 7950X, all cores, maxed out with Prime 95, the fan on the power supply didn't even spin. So really awesome power supplies. Can't say enough about them. That's one of the most crucial components in a system build. I remember in the early days, in the late 90s, early 2000s, there were so many junk power supplies out there. They would say they were rated at 400 watts, and that was like 400 watts peak max for like 5 seconds. And I remember one brand, I think it was called Palmax, and I mean, that's really the truth. It sounded like it was gonna, I just thought it's gonna, those caps are gonna blow. It's gonna pow. And so I'm thankful there's a lot more selection today and quality power supplies available, but I'm sticking with the tried and true Seasonic. And again, call me a fanboy in that area, but if you find something that is reliable and works, just stick with it. All right, well, moving on to the next thing on the list of components we chose for this server build. And again, you can feel free to leave a comment if you're watching, and I can maybe answer any questions you have. So this is, of course, the dust filter, the little dust screen magnetic one that I purchased for the purpose of covering out that hole that I cut in the top of the lid right above the heat sink for the CPU. Now let's talk about the storage. This is the title of the video, right? An all-flash server. And so here's what I did. There's no spinning disk drives in this server. And this server is going to a medium-sized doctor's office. And so how did I accomplish that? Well, a lot of the money was spent in storage. Now I will say this was purchased around November last year when the price of, for example, of the Samsung 990 Pro 4 terabyte NVMe drive was actually around $250 to $275. They were just really, I guess they had a lot of quantity of these out in the market, and they were selling for an excellent price. They're way more expensive than that right now, and I hate the way prices of things fluctuate. I hate how they artificially inflate those. In fact, Samsung announced, I believe about a month and a half, 2 months ago, that they were purposely slowing down production of their NAND flash memory in order to be able to increase the price, really, in their profitability. So, I mean, I get it. They're out for profit, but it is sad for the consumer that, now the same drive costs almost $100 more. Let me explain how I have these drives laid out. And I do have more than one model of these. Before we do, though, the read speeds on these, the sequential reads are rated up to 7,450 megabytes per second. Read speed 7,450 megabytes per second read speeds, 6,900 megabytes per second write speeds. And of course, you have to be in a PCIe 4.0 times 4 slot in order to get those kind of speeds. If we scroll all the way down here, there is a full spec sheet on these, and you can see their random read IOPS, random write IOPS, and some of those things that you might be interested in. And so let me just kind of move over here and we'll talk about what we've got. So if I transition over here, what you'll see is over on this side, I believe it is, I have two 1 terabyte Samsung 990 Pros. These two drives these are the boot drives. They're together in a RAID 1, a mirrored array. I'm using software, basically mirroring. I'm not even using the chipset RAID. I'm going to explain that real quickly before you say, well, aren't you using the chipset RAID? Why are you using just the RAID option in Windows Server 2022? And I'll explain why. So I have used Intel chipset RAID for many years, even decades, with very little issue. It's even at times possible to take those drives, whether it's a RAID 1 mirror, a RAID 5, with parity, 4 or 5 drives. If you do it correctly, you can oftentimes even move those into another chassis if there's a major issue, and you can get that data off those drives because it'll kind of recognize that RAID array, if you will. And so had very little issue with Intel chipset RAID. Maybe your mileage may vary. But when it came to AMD chipset RAID, I built a similar server. It was the previous generation Ryzen processor, the socket AM4, and I went ahead and I used chipset RAID, AMD chipset RAID. It requires special drivers, 3 drivers in fact, to be installed just during the server installation if you're using Windows Server. And on top of that, basically your partition and file system, they live kind of hidden behind this kind of proprietary driver, if you will, this kind of proprietary RAID chipset, and because of that, it becomes very difficult if you need to try to recover data off of a drive, or if you need to try to rebuild that array on another system. It's going to have to be in a system with an AMD chipset, and it's going to be clunky if you try to use like a Linux live disk and you want to try to access those, even if they're in that RAID array in the BIOS and the chipset. It was nearly impossible when I was trying to install those AMD drivers in a Linux environment. Thankfully, I was able to get all that data back. And you say, well, how did you lose data? Well, I learned the lesson the hard way. If you might remember, there was a known issue with the Samsung 990 series with some certain particular firmware versions where the drives would wear out so prematurely. And it was really an algorithm issue, and it was a bug in the firmware. And the drive thought it was full. It thought it not really full as in the sense of being capacity, but the maximum number of writes that were allowed for that drive in its lifetime had been reached. It would not allow any more data to be written to that. Well, I had these drives in a RAID array, which makes it very difficult to do firmware updates to the drives when they're in that chipset RAID scenario. You had to boot off you had to take them out of RAID mode, boot off of a USB flash drive, try to update them. Long story short, I had one of those drives that failed because it had that older firmware version on it, and I drug my feet too long trying to get the firmware updated on those because it was out in a production environment. And so, but I was able to get all the data back by using a low-level recovery software, just basically using DD Rescue and Linux and making an exact copy of that drive and then putting that on a new in that case 2 terabyte NVMe Samsung 990 Pro, get all the firmware updates I needed, put that back in the system, all the data was there, everything was good. It's a little scary, but everything worked out. And so because of that, I'm leery of AMD chipset RAID, and so I'm using the software RAID. These two, just using, basically you can use disk part or disk management in Windows, and you can put these in a RAID 1 mirror. And then I did go through the trouble of, Microsoft has some documentation how you can make it where if either one of those drives fails, the system will still boot. There's a lot of additional steps, probably take you at least 30 to 45 minutes, maybe even an hour to follow those to create some additional partitions to mirror. In other words, you have to have an EFI partition to be able to boot off those and some other things. And so just keep that in mind. Then, for the primary, I guess you'd say front and center storage for the server, I have 4 terabyte Samsung 990 Pros. I have all these in a storage spaces mirrored set. And these 4 drives here are also all running on a bifurcated card, a PCIe 4.0 PCIe times 16 4.0 bifurcated card. And that brings up another important topic for just a moment. If you want to be able to have the maximum amount of solid state storage in a server, you're going to run out of M.2 slots on the motherboard really quickly. In fact, this motherboard, this ASRock rack board, only has one M.2 NVMe slot on the motherboard. So if you're going to add other M.2 NVMe storage, you're going to have to use a riser card. There's 2 types of riser cards available for, like, let's say a 16x slot. One of them actually has a chip on there that acts kind of as a brain, if you will, to control these 4 drives so they can all be accessed and used, because each one of these, to be used to their full capacity, needs a full 4x of these PCIe 4.0 lanes. But those cards are more expensive and they're more complicated and not the way I wanted to go. So what you can do is, if you buy a motherboard that supports bifurcation, it takes that 16x PCI Express slot and it divides it up either into 2 8x slots, if you will, or 4 4x slots. It's still just the same physical slot, but it divides those PCIe lanes. So the 16 lanes are divided into 4 sets of 4 lanes. And so this particular riser card here, and we'll talk about that in just a moment, allows you to have 2 NVMe drives on this side and 2 NVMe drives M.2 plugged into the back as well. And they all have their own dedicated 4 lanes to the motherboard and to the processor. Those are direct to the processor lanes. And so that's something you may not be aware of, but you've got to make sure, if you buy one of these riser cards that says it needs bifurcation, that your motherboard supports that. It's a BIOS setting. You go in there and you change the way that 16x PCI Express slot is laid out, and you say you want it divided up into 4 4x lanes. And so we'll talk more about, you may say, again, another critique I may hear is, why did you use storage spaces? And I'll talk more about that. And but I'm so far been very pleasantly surprised, and we'll talk about that in just a second. So as I transition back over to the video here, that brings us right into these riser cards. And again, you might say, it was kind of questionable, why did you buy these off AliExpress? Well, this was the best card I could find at the time. ASRock Rack makes a bifurcated PCIe times 16, that supports 4 NVMe drives, M.2 drives, but it was out of stock everywhere around November of last year. In fact, I don't know if they were decommissioning or getting rid of that particular model. And so I could not find the ASRock Rack model. I tried some other brands I purchased off Amazon, like JEYI, and I had really bad issues with those. I had computer rebooting randomly, shutting down and rebooting, a lot of instability, blue screen type stuff. And so I did a lot of research, and these link reel are really good quality. You can tell on the traces, they take the shortest path possible, from what I can tell, and they just seem to be very well built. And so these are available. You can find some of their variants or their different models of riser cards. Some of those you can find on Amazon or you can find on Newegg, but I couldn't find the exact one I wanted, so I went out there and found them basically direct from them on AliExpress. And so also, because I mentioned earlier, the motherboard only has that one M.2 slot, but I have two of these 1 terabyte drives in a RAID 1. Where did the other one go? Well, right above that 16X slot on the motherboard, there was another 4X PCIe 5.0 that goes straight to the CPU. And so I bought this other riser card for a single M.2 NVMe drive, and that one and the one on the motherboard are together in that RAID 1 mirrored set. And so this is the card I bought for that. And just to give you an idea, and you might say, oh, you use storage spaces, I'm sure it killed your performance. Well, take a little gander at this screenshot. And this screenshot is not even accurate. I forgot in Crystal Disk Mark, you're supposed to go in and select that you're testing an NVMe drive, and I did not do that. So my random 4K, Q depth of 1 and all that are not as good as they ought to be. So when you see those numbers, don't get alarmed. But just to look at that sequential read and write speed, it is taking full advantage of all 4 of those drives, and my sequential read speed was almost 27,000 megabytes per second. Sequential writes, of course, are more on parity of a single drive, which is just a little bit under 8,000 megabytes per second. And you'll see down there your random reads and writes are what really matters in a real-world scenario, and those kind of drop down to more normal numbers. And again, those numbers would be better if I would have toggled that NVMe setting, and I haven't had a chance to rerun this test on the one server that's already out in production. The other 2 are just kind of built and put together. Need to get the OS loaded and those kind of things. And this one's not even built yet. All the parts are here in front of me. So if that gives you any kind of indication of what you could expect, even using storage spaces by Microsoft. So what chassis did I choose? And if I went with anything a little less expensive on this build, the one thing I probably used that was less expensive was I went with the Rosewheel RSV-Z2600U. I went with this chassis specifically because it supported a micro ATX motherboard, which the ASRock rack board was. It also gave me, able to use a traditional power supply, just a normal ATX power supply. And I had basically the qualities I was looking at. But the number one most important quality really is this had to fit in a wall mount cabinet that's about 24 inches deep. So this particular 2U chassis is only 15 inches deep. So they fit all that, a micro ATX, not an ITX. We're talking about a decent sized motherboard, a micro ATX board, a normal size power supply, and it can support up to 4 hard drives as well. Although I don't have any spinning disk drives, I do have 2 SATA drives that are, these are SSDs. I'll talk about it in a little bit. But this is the chassis that I chose. And so it's very basic, very simple. It's nothing fancy, but really there's not really much in the way of electronics on a case. You want to make sure you got USB. This one does have USB 3. I think the one I have is a little bit older variant. I think it has one USB 3 and one USB 2.0. Has power and reset, has your hard drive activity and power LED lights there. And it is in a 2U form factor. And that's kind of what it looks like there. There are vents or cutouts on this back corner where the ATX power supply goes, so you don't have to worry about that if you're using just a standard power supply. And so that's the chassis I just picked, and that's the reason why I picked it. And so you have to keep that in mind. A lot of these wall mount cabinets are not even that deep. But this one was still working a little bit shallower case, or a little bit shallower cabinet. That's something also to keep in mind if you're building out a cabinet. I would recommend the 24-inch deep cabinets just because sometimes your battery backups or your network switches, especially 48-port switches, some of them can be so deep that anything shallower than a 24-inch, about 650 millimeter deep cabinet, you'll end up having problems. Trust me from experience. And so we talked already about the cooler. Well, the fans that I chose, because this case does have 3 80-millimeter fans on the front drawing air in. And, of course, those fans had no control. They just had a normal 4-pin Molex connector, plug straight in your power supply. And without some kind of special fan controller, you have no way to control the variability or speed of those fans. So, of course, I replaced those with Noctua. And I went with the NF-A8, and these are the PWM models, the 4-pin connector. This motherboard does support, has all the I think they actually even have more pins than 4 for the newer style fans. But the motherboard is able to control the fans based on I just have it set on the default curve. So as the processor gets hotter, the system gets hotter, then the fans will ramp up and speed up. But when it's just kind of idling, it's super quiet. And again, it takes some time to take the front I take the entire front of the case off in order to get these fans swapped out, but it's worth it to me. And so there you go. Without further ado, one of the ones I've already built, I believe this is one that's already out in production. This is what it looks like on the inside. So you see the 3 Noctua fans, 80mm fans drawing air in. You see that Noctua NH-L12S cooler has that fan mounted on the bottom in order to give you the maximum amount of cooling in that amount of space. And like I said, there's just about 1 millimeter of space between the top of the heatsink and when the lid is on there. You see the smaller riser card for that one single NVMe drive in that 4X slot, and then you see those 4, you only can see 2 of them, of those 4X times 4 in that 16X slot there, of those 4 terabyte NVMe drives. And then you see the power supply, and you finally get to see the final part of this all-flash build. There are 2 Samsung, and I believe these are 870s. I didn't pull up the specifications on those, so I'm going to grab it off the table. Yeah, these are the Samsung 870 QVO, and these are 8 terabytes each, also in a software RAID 1, to give a total of 8 terabytes of space. I can use a scratch paste backup space using Veeam or something like that. In most of these locations, I have another backup target, like a Synology NAS or something, but it is nice to have that additional space on the server if it's needed for temporary backups or even permanent backups that get mirrored or copied off that server or off-site. And so that's how I was able to stick with all flash. Now you say QVO, that's a QLC NAND, and so that's not going to last as long. I get that, but at the same time, this is not the production data. This is just for backup. And so the price you couldn't afford, probably I couldn't have afforded an 8 terabyte SATA drive, a solid state SATA drive, if it was like even TLC, and for sure if it was like MLC or something like that. I don't even know if there's really many MLC drives with that capacity actually. And so there you go. The memory's there, just above the heatsink. And that's what it looks like. I'm going to go ahead and go to the next picture. You can see a top-down shot. Don't give me a hard time because I didn't clip that zip tie. I have snips, so I'll clip it at some point. But actually, this one's already in production, so I just have to go next time I'm in there or something. But that's what it looks like. You can finally see that M.2 NVMe slot on the motherboard, the single one it has there. And you can kind of see how my cable management is. I mean, it's not perfect, but it gives plenty good enough airflow. Try to keep those 8-pin CPU power supply connectors flattened down on the bottom of the chassis as much as possible, as well as the normal ATX power connector from the power supply. And I think overall it looks pretty good. And then you can see kind of a close-up of how much space there is between the top of the heatsink and the lid there. And there is very little space. And but it was a fun build. I really enjoyed it, and think it's something that maybe you were intrigued by, interested in, or maybe you were just bored to tears. But at any rate, this was a different platform, I guess, and a different kind of style of video. And I just want to kind of take you along for the ride and show you why I chose the components of a all-flash server build. Again, not necessarily inexpensive, but I'll talk in a moment about an alternative option that you have if you need to build an inexpensive server. I do hope that we'll see some comments, some questions. I'd love to answer those. I'd love to hear what your thoughts are and what you would have chose if you would have been building a similar type server. And if you have any questions, please let me know. I'd love to answer those if I can. And don't have all the answers, but I've been doing this a long time and I've learned a lot of things. And so I think that kind of rounds out the components I chose and why I chose them. And if there's something I forgot or missed, well, so bad. And one thing I want to mention, you noticed over here on this side, there's a little guy kind of hanging out. And you say, what's that doing there? That has nothing to do with the server, and you're right. This is a Minis Forum UM790 Pro, And that is just a really awesome little AMD mini PC that is perfect if you need to build a server for a small business and you don't want to spend $6,000 on an all-flash, super fast system. And so let's go ahead and switch back over here, and I'll kind of show you what I'm talking about. If I go over here to our pictures we're looking through, this is the inside of that UM790 Pro Venus series from Minis Forum, and these go for an excellent price. I was able to build this entire server, not counting software licensing cost, anything like that, for around $800, but I used really good components. I put two Samsung 990 Pro 2 terabyte NVMe drives in here. I put, switch over here and I'll show you the memory. So this, before we get to the memory, I'll show you a little more details. The UM790 Pro has the AMD Ryzen 9 mobile chip, the 7940HS. If you look at the specifications there, it can boost up to 5.2 gigahertz. It does support dual channel SODIMMs, 5600 megahertz up to a maximum of 64 gigs. It does have those two M.2 NVMe drives, or bays or slots, I should say. And if we go to this last little shot here, here's the memory I chose. I chose this specifically because it is an ECC memory module. It is the DDR5 5600 that we needed, but also it's ECC. It's an unbuffered DIMM. It's ECC memory. And so that's why I specifically bought this Kingston kit. The best place I could find it was on Mouser, so that's where I purchased it from. It's not necessarily cheap memory, but it is ECC. It is kind of debatable whether or not this CPU supports ECC memory. I'm finding conflicting information online. Some things say it does support ECC, some say it doesn't. I know the generation of chip it's based on certainly does. And one thing I have not been able to do yet is take the time to run like MemTest or some other program that can check and see if that ECC is actually being taken advantage of. If I remember correctly, when I built this little mini PC server, I did not see a particular setting in the BIOS that, to toggle ECC on or off, or maybe actually I did. Maybe it said it was there. I can't remember. I have to look back and let you know later. But yeah, this is the drive I chose, and you might have noticed you might call me a Samsung fanboy as well, I suppose, but I've always had really good reliability and experience with the Samsung 990, well, any of the Samsung NVMe drives, the Samsung SATA drives. That's by and large the brand I bought more than any other SSD is Samsung. I did have that one really poor experience with the 990s with the old firmware that caused them to, inaccurately say they were at end of life and full as far as maximum rights have been reached very prematurely. And so I'm a little bit gun shy, but make sure all these have the latest firmware on them. Shouldn't be a problem. And so, here we are. It is quite a while later now. I'm going to see if I can switch back over here and we'll conclude this video. I'm not sure if I'm going to take you along for the ride as far as like live streaming the build, but what I do intend to do is at least videotape myself building the server, so I kind of take you along for the ride with that. And but yeah, I think that's just about it. Again, this is Kevin with Custom Micro. It's been difficult trying to get this video made. It's our first live stream. It's our first video of this format, and it's in a new location with new equipment that I'm using. And so it's been a challenge. I'm glad it worked this time. I'll have to go back in and edit some of the beginning of the video where there's just a lot of lead-in music, and the audio was messed up for just a few seconds, and I'll fix that. And but I would please leave a comment. I hope you find this video, share this video. If you've not subscribed, because maybe you thought, oh, I ran across this video, but they haven't put out a video in over a year, go ahead and subscribe. We're going to have more content coming. I'm dedicated to that. I really love what I do, and I want to bring you along for the ride of that. And I hope you enjoy technology as much as I do. And again, go ahead and subscribe, like the video, and if you hit the bell notification, you'll know if we go live. You'll know the next time we put out a video. And other than that, have a great evening. This has been Kevin with Custom Micro. We'll see you later.